In this video, we will be talking about basketball. Basketball is a high-intensity intermittent court sport over 4 quarters. At NBA rules, it is 4 quarters of 12 minutes. At FIBA and NCAA, it is 4 quarters of 10 minutes or 2 halves. It has unlimited substitutions, which means higher relative intensity per playing bouts. The positions include guards, wings, and centers. The physiological demands. The sport has short duration, high intensity with frequent recovery opportunities. It's got frequent accel and decelerations, repeated short sprints, jumping density is about 40 to 70 plus per game. The high speed running and threshold in literature, sprint is about 18 or 20 kilometers per hour, lower than field sports. True maximal velocity is rarely reached in competition. Some biomechanical demands. The key movement patterns are rapid accel into decel cycles, lateral and multiplanar change of direction, repeated jump landing sequences, reactive movement in response to opponents. The mechanical loading include high eccentric load during braking, high vertical ground reaction forces on landing, significant tendon loading. It is the most eccentrically demanding team sport. Accel and decel demands. Accel is frequent but short. Decel is equally frequent and more mechanically demanding. It is greater eccentric force than acceleration. High decel loads associated with increased fatigue and injury risk. The programming targets should include braking capacity, force absorption ability, efficient reacceleration mechanics. The position type differences. Guards have highest acceleration and change of direction frequency, highest movement density. Wings has a mixed demands of speed jumping and COD. Centers has lower movement volume, higher jumping frequency, and more contact demands. Some common injuries include lateral ankle sprains, ACL injuries, and patellar tendinopathy. Modifiable risk factors include poor landing mechanics, insufficient eccentric strength, spikes in jump and deceleration load, and poor braking technique. The first exercise is the reactive change of direction, COD. It improves reactive movement efficiency, perception action coupling, and reduces risk on unplanned cuts. The exercise is a 6 to 8 reps of 5 meter acceleration and then a reactive cut to any direction on a visual or verbal cue. Rep distances is 5 to 10 meters, rest is 60 seconds, work rest ratio 1:5 at high intensity. Because basketball is very dominated by unplanned movement, so planned COD drills will undertrain the actual stimulus. Reactive COD differs biomechanically from pre-planned COD in joint loading profile. It trains coordination under reactive load and lowers joint loading via improved mechanics. The second exercise is deceleration capacity training. This exercise improves eccentric braking capacity, force absorption, ACL, patellar tendon injury risk reduction. This exercise will be performed 5 to 6 reps at 10 to 15 meters maximal sprint and decelerate within 3 to 5 meters. The rest time is 90 seconds, work rest ratio 1:5, intensity is near maximal sprint. Rapid offense to defense transitions in a confined space demand very high eccentric quad loading, often exceeds accel demands. Poor decel drives anterior tibial shear, knee valgus loading, and ACL strain risk. Progressive exposure increases tissue tolerance and reduces overload in competition. Workout number 3 is a vertical jump. The training goal is to improve jump repeated jump performance under fatigue, tendon stiffness and elastic return, SSC fatigue resistance. The exercise will be 3 sets of 8 maximal effort vertical jumps with total of 24 jumps at 2-minute rest between sets. This exercise is good for rebounding, shot blocking, and finishing, rely on stretch shortening cycle. Elastic energy return drives performance. Fatigue reduces landing control, raising joint loading and injury risk. Trains motor unit recruitment consistency under fatigue, and improves tendon capacity. And this is the works cited page.